Okay, so we will start with the topic of equilibrium, but before we have that, we need to have what we call the support reactions. Okay, so in the previous topics of statics, we have already discussed the resultant. So para rin tong resultant, except that all the forces is zero. Okay, so for now, we will deal with coplanar forces. So when we say coplanar forces, they lie on the same plane or two-dimensional slang. Okay, so we have six now. So in general, we have six degrees of freedom or reactions. We have the forces X, forces at Y, and forces at Z. That is the direct forces. And we have a couple, which is the moment at X, moment at Y, and moment at Z. However, in planar forces or coplanar forces and coplanar equilibrium, it will just be reduced into three. So, meron lang tayong summation forces X, summation forces Y, and then summation moment at Z. So, magiging tatlo lang. Okay? So, alamin natin yung iba't ibang klase ng support reactions. So, una, we have what you call the roller support. Okay? For a roller support, it has just one reaction. It is a translation and it is normal to the plane of support. Okay, so when I say two-dimensional, so we can have only the X and then the Y. Okay, and then we have this symbol, a roller. Okay, o kaya mga gulong. Okay, kung mga bilog-bilog. Okay, basta bilog siya on a surface, so normally that is a roller support. Okay. So, iba-ibang books, iba-ibang references, iba-iba yung symbols nila. Okay, pero sinasabi naman doon sa book kung ano yung support nila doon sa roller. Okay? So, if this is your roller, your reaction would be one translation. Okay, isang direct force lang. And it is not always parallel to the X or parallel to the Y. But it is always perpendicular. Okay? So, it is always perpendicular dun sa ating pinaka-surface. Yeah, for example, like that. So, what if our roller is somewhere inclined like this one? So, again, yung kanyang angle, it's always perpendicular dun sa ating surface. Okay? So, whatever it is. So, kung paganto naman yung ating support, okay? So, for a while, yan. Kung ganyan naman yung ating support, okay? So, you can have this kind of reactions. Okay? So, I want you to see that this roller support, okay, of course, when we are dealing with just computation, drawings lang yan, okay? But in actual, ito po yung ating mga roller supports, okay? So, on the first picture, you will see, on the second, also, those are the supports on the bridges, steel bridges. Okay, that is a roller support. Okay, so also on that, okay, so you can have here a roller support. Okay, ayan. As well as for this one. Now, itong pang lima, okay, it is not necessarily a roller, hindi siya gulong, okay, pero imagine that your beam, ito po yung ating beam, okay, ayan yung ating beam, sample lang, and it will try to move on these directions. Okay? So, because of this called slotted hole, okay, slotted hole, okay, so ang nangyayari sa kanya, it will just tend to move without reaction. So, medyo free siya, no, mag-slide. So, it means, in actual, that is a roller support, but in drawing, nilalagyan natin siya dito. So, we have that kind of roller support. Okay? So, ayan pala, no? So, ayan, slotted din pala dito. Okay, it means it is free to move back and forth and it is free to move up and down. Okay? Well, this one, okay, eto siya, pag ganyan lang siya. No? So, meron lang siyang reaction dun. But, it is free to move on this direction. Okay? So, that is a roller support. Always remember that the reaction, again, of the roller support is always perpendicular to the plane of the roller. Okay? So, that's one. So, meron ka lang isang reaction kapag roller. How about the second one? It's called the pin or the hinge. So, on the pin or hinge, meron ka namang dalawang reactions, no? So, the first one, okay? So, for example, this one, we can simplify this one, okay? So, since mas madali para sa atin na kino-component natin yung forces, pwede nating sabihin that the pin or hinge has always two reactions. Okay? Isang always parallel to y and always parallel to x. Okay? So, yun yung gagamitin natin. Ano? So, although, syempre, depende dun sa magnitude niya, meron talaga siyang reaction. Isa lang naman talaga yung reaction niya, no? So, you have that one reaction supposedly. But since for simplicity, no, ginagawa natin, kino-component natin yung resultant niya into x and then y. That's why, for this one, we can say that the pin or hinge has two reactions. So, pine-prevent nila yung translation or yung movement ng joint on the x and then on the y. Yung roller, isa lang, pine-prevent lang yung pag-angat, pero it is free to move horizontally, no? Kung nasa plane of support siya, kung yung roller mo ay nasa horizontal. While the pin or hinge, hindi siya pwedeng gumalaw. Pero allowed naman siyang mag-rotate. Ano yung mga perfect example niya? Okay, later on, no, papakita natin. So, in pin or hinge, whether you have a slanted or a perfectly vertical or perfectly horizontal, we can assume that their reactions are always parallel to the x and then to the y-axis. Okay? No matter what the orientation would be. Okay? So, kaya dito sa pin or hinge, meron tayong dalawang reactions. Isang parallel sa x at isang parallel dun sa y. Okay? So, ano na may mga examples in real life ng ating mga hinge support? Yeah, so those are the hinge supports. Okay, so it prevents us to translate. Yeah, kagaya nung sa unang picture, itong joint mo na to, hindi siya pwedeng mag-move here, hindi rin siya pwedeng mag-move over there. Okay, pero pwede siyang umikot-ikot. Okay, it allows a rotation on this kind. Okay, same thing for this one. Okay. So again, ang reactions niyan, so isa 1 and then 2. Palagi kang merong dalawang reactions. Okay? So the last one is what you call the fixed. Okay? So we have 3 reactions, dalawang translation, and isang rotation. Okay? So we have 3. So hindi niya pine-prevent yung joint na to umangat because of this reaction. Hindi rin siya pwedeng mag-move horizontally because of this reaction. At hindi rin siya pwedeng mag-rotate back and forth on that direction because of the rotation or the moment. Okay? So with this, ito yung mga fixed support natin. Ayan, kagaya niya. No? So kung makikita nyo yung mga stanton ni Jollibee, no? So yung mga pylon. So hindi siya pwedeng nakapin. Kasi kung sabihin natin pin or roller, so, ang ano lang niya is nakaganyan siya. Okay, so sabihin natin nakakawit siya ng ganyan. Ano? So, hindi siya mag-move back and forth, pero it will free to rotate. Tutumba lang yun. Okay, so it would become unstable. Kapag fixed, para kang nakahawak na ganyan. Ano? So, hindi siya mag-move here, hindi siya mag-move pataas, at hindi rin siya magpe-prevent ng rotation. So, kahit anong tulak mo. Okay, so it's because meron kang support na nagpe-prevent ng rotation. Okay, so kapag dalawa, isa or hanggang dalawa, halimbawa, sample, ano ba magandang example? Okay, kung napupunta tayo ng EDSA, for example, ano, yung highway. So, yung highway. Okay, so may dalawang lane. Tapos, meron dong signage, ano, yung mga signage ng MMDA. So, for example, ayan, signage, ano, nakalagay, to SM North, okay, or to Bulacan, okay. So, meron kang dalawang columns, okay. So, yung support niya, okay, dalawang directions ulit yan, ano? Meron kang direction dito, and then meron kang direction doon, okay? So, ito, dapat, yung pagantong ikot, okay, let's say X and then Y. So, yung moment mo sa X, it is required to have a fixed connection. Otherwise, tutumba siya, okay? Kasi, hindi siya nagpe-prevent ng rotation, okay? Pero, yung paganto, yung moment, ayan, pwede mo na siyang ipin. Okay. Later on, we will have that, no? Pero generally, sample na, generally, kapag meron kang one-legged structure or two-legged structures, so you can have a fixed support on that. Kapag meron ka ng three-legged structures, pwede ka nang mag-pin. Okay, ibig sabihin, hindi na siya tutumba, no? Okay, so we will go on further that, no, in your theory of structure subject. But for now, for ecoplanar forces na mayroong fixed support, meron kang tatlong reactions: vertical, horizontal, and rotations. Okay? So, it's our four reactions, and then still we will move with the other types of support sa structures po. Now, okay. So in our book, we can have different kind of support. So the first one is a flexible cable. Okay. So of negligible weight. Okay. So later on kasi yung mga cables natin, for example, yung mga wires ni Meralco, wires ni PLDT, okay, yung malalaking wires no. So meron siyang mga weight. Okay. So kukumpitin natin yun soon. But for now, dito muna sa coplanar forces, ina-assume natin na yung mga tension natin or mga cables natin, it is always negligible weight. Okay, so mag-i-introduce na ako ngayon, although wala pa tayo dun sa ating trust members. Mag-i-introduce na ako ng forces. No? So kapag yung isang bagay ay hinihila mo, okay, that's called, or pulling, okay, pulling, it receives a tension force. Ang tawag natin dyan is tension, okay? Kapag naman itinutulak mo or you are pushing, okay, yung body, pinitipi mo, okay, it is called a compression force, okay? Si cable po, hindi po siya nakaka-experience or hindi siya nagre-resist ng compression forces. Ang nire-resist lang niya is always a tension force, okay? Palagi lang pong pahila, okay? So, kasi kapag imagine yung sinulid, okay, you try to push it, so mangunguluntoy lang siya, no? So, it means walang resistance kapag pinush mo siya. Pero kapag hinila mo siya, okay, so mapapansin nyo, minsan, di ba, mahirap hilahin, okay? So, again, it receives the tension force, okay? So, the second, it's like what you call the roller. Parang roller lang po ito, no? So, kaya lang, it is rest on a frictionless, okay? So, isang magandang example niyan, kung nag-ice skating kayo, no? So, yun. So, kahit nakatungtong ka, syempre, hindi ka naman lulubog, ano? Because meron kang reaction dun sa baba, pinaka-sapatos mo. Pero again, nagmo-move ka in any directions, no? Nagmo-move ka. It's because you are on a frictionless surface, okay? So, sa mga yellow, o kaya kapag may mga oil, okay, those are frictionless surfaces. And its reaction also has one reaction. It is always, ayan, kagaya nito. Okay. It is always, okay, this one, ano? Perpendicular. Okay, palagi po siyang perpendicular dun sa ating surface. Okay? Now, if your theta is in the horizontal, okay, pagdating po dun sa reaction, manggagaling na po siya dito sa vertical. Nandyan na po yung inyong theta. That would be your theta. Okay? So, ito rin, yung reaction po nito, okay, lagi po yung tension, but the reactions of the cable is always parallel to the line of the cable. Okay? Kung nasan po yung cable, nandun din yung kanyang reactions. Kagaya po nito. Okay? So, you can have that. Okay? So, ito, nabanggit na natin, we have called the roller support. Ayan. So, again, yung roller support, it's always perpendicular, ano? Perpendicular po dun sa ating surface. And if the horizontal came, okay? If the horizontal came from here, from the horizontal, if the force or inclination came from the horizontal, pagdating po dun sa reaction, para maging perpendicular silang dalawa, manggagaling naman po siya dito sa vertical. Okay? So, ayan na. So, nagkakabaliktad. Okay? So, how about this one? Although wala pa po tayo dun sa ating topic na friction, but we will be having this kind of reaction. If on the problem it states that the surface is not frictionless or consider friction, ibig sabihin, aside from the perpendicular force na meron ka rin na force parallel dun sa surface. Okay? Which is yung dalawa perpendicular naman. Tawag natin dun sa perpendicular force is normal, at ang tawag natin dun sa parallel is a friction. Okay? So later on, we will compute that frictional force. But for now, we must know that in a friction surface, meron po siyang dalawang reactions, normal and then tangential or parallel po. Ano? So again, we have pin support or the hinge support. So, yun yung pinakita ko po kanina. meron kang dalawang reactions doon. Okay? While the cantilever or built-in, pag narinig nyo po yung built-in, cantilever support, or a fixed support, okay, meron po siyang tatlo. Okay? Yun, yung mga stante po ng Jollibee, tawag yung mga cantilever na, no? So, ibig sabihin, isa lang yung point of reaction niya, and it is a fixed support. Okay? So, tawag po natin doon ay fixed support. Built-in kapag narinig nyo doon sa pangalan. Okay? So, ayan, meron naman po doon sa book. Okay? So, that's it for the type of supports. Now, after we have discussed all the type of support, dapat po alam natin gumawa ng free body diagram. Ano po yung free body diagram? So, free body diagram, kasi kapag sa figure, sa mga problem, given po yung mga supports, okay? Ngayon, ang gagawin natin, kaya po tinawag siyang free body diagram, no? Ibig sabihin, it is free from the supports. Tatanggalin natin yung mga supports, tapos lalagyan natin siya ng mga forces and moments. Okay? Papalitan natin siya. So, kailangan matuto po muna tayong gumawa ng free body diagram bago tayo makapag-solve ng equilibrium reactions. Okay? So, that's it for the types of support, and we will discuss the free body diagram on our next lesson. Okay, so let's have the sample problem on the book, no? So, homogeneous 6-meter bar. Okay. Unahin natin yung word na homogeneous. Okay. So, when we say homogeneous, it means yung pinaka-weight niya, kung given man yung weight, tumatama po yun sa gitnang-gitna or sa center ng ating bar. Okay, so meron daw siyang 6-meter bar. Ito po yun. Okay, so you have there the 6-meter bar. Okay, tapos homogeneous siya. It means kung meron man yung weight somewhere here at 3 meters, meron po yung bigat. Okay, yung bigat na atin. Okay, so is supported in a vertical plane by rollers. Ayan, binigay, sabi daw rollers at A and B. By a cable at point C. The mass of the bar is 50 kilograms. Draw the free body diagram of bar AB and determine the number of unknowns on the FBD. Okay, free body diagrams. Okay? So, ang unang step is, idodrawing mo muna yung body na kailangan mo. So, ito, kailangan lang natin is the bar ABC. So, ito po siya. Dinrawing natin yung bar A, B, C. Okay, ayan yung bar ABC, ano? So, yung total na yan. Okay? Now, ilagay muna natin lahat ng external loads. So, pag sinabi kong lahat ng external loads, hindi po yung mga support. Okay, yun yung mga forces na tumatama doon sa ating body. Ano yun? So, we have what you call the weight, no? So, meron daw tayong mass na 50 kilograms. Okay? So, para maging weight po siya, so yung 50 kilograms, imumultiply po natin sa acceleration due to gravity. So, yung 50 mo, imumultiply mo yan by 9.81 meter per second square. Okay? So, once you have that, makukuha mo na yung weight. 491. Again, the unit now is in Newton, which is a force. So, sabi nga natin, tumatama yon sa gitnang-gitna. Ayan, kung mapapansin nyo, that is a 3 meters and 3 meters from two supports or from two ends. Okay? So, that's one. Iyan lang yung nag-a-act doon sa ating bar. Okay? However, since this is a free body diagram, tatanggalin natin yung support. Okay? Tatanggalin ko yung support sa A. Kaya lang, papalitan ko siya ng force. And since this is a roller, it means doon sa surface niya, meron ka lang isang force which is excuse me, perpendicular sa kanya. That is a normal force. Okay? So, tatawagin natin yung NA. Okay? Kaya pinalitan po yun ng NA. Next, on the point B, okay, meron ka ring roller. But again, this is your surface. So, it means meron ka po dong perpendicular force since it is a roller. And that is normal to B. Kaya po, ang tawag natin doon is N sub B. Okay? And then lastly, at point C daw, meron ka daw cable. So, sabi ko natin kanina, yung cable natin, it is always okay, on the line of action of the tension cable. Okay? So, papalitan din natin yon ng tension T. Again, kung ano yung kanyang angle, yun din po yung inyong angle. So, wala ka ng ibang reactions. That is now the complete free body diagram of the bar ABC. Bibilangin mo na lang kung ilan yung hindi or yung unknown. Okay? So, meron tayong isang unknown, 1. Meron tayong pangalawang unknown, 2. At meron tayong pangatlong unknown, which is 3. So, ang mga unknown sa kanya is NA, NB, and then 3. A total of 3. Okay? So, meron kang tatlong unknowns. So, kapag meron kang tatlong unknowns, maximum, pwede natin siyang masolve gamit ang statics. So, yung statics kasi, again, meron tayong equations. Summation forces X, summation forces Y, and summation moment at Z. So, it means tatlo yung maximum unknowns para ma-equate mo sa tatlong equations. So, you can have 3 equations, 3 unknowns. It means it is solvable by statics. Kapag naging 4 na po yung unknowns mo, so hindi na natin siya masosolve using simple statics. We need to have the knowledge of deformable bodies or theory of structures. So, ang tawag po dito, okay, kapag tatlo yung maximum unknowns, tinatawag po natin siyang statically determinate. Okay? Statically determinate structures. Okay? Kapag naman po naging 4 or mahigit, ang tawag po natin sa kanila is statically indeterminate. Okay? Indeterminate structure. Okay? So, itong mga structures na to, again, they are not solvable by simple statics po. Okay? So, that's it for the sample problem 4.1, and we'll proceed with another example. Okay? So, let's have this problem 4.2. So, homogeneous 250 kilogram triangular plate in figure A is supported by a pin at A and a roller at C. Draw the free body diagram of the plate and determine the number of unknowns. Okay. So, again, ang meron lang sa kanya is yung pinaka-weight niya. So, i-drawing muna natin yung pinaka external loads niya. Okay? So, we can have 250 kilograms. But this is a triangular plate. So, yung pinaka-centroid po ng triangular plate natin is located somewhere. Okay, here. Okay, so meron po yung 90 degrees, for example. So, from the 90 degrees, yung centroid po niyan is always 1/3. Okay? So, lagi po yung 1/3 ng length mo. So, ito is 0.6. Okay? So, it will become 0.2 meters. So, palaging 1/3. So, mula naman dun sa pinaka-point, so 2/3 naman siya, no? So, you can have it as 2/3 of 0.6. Ito, ganun din. 1/3 yan palagi from the 90 degree. So, you can have it as 1/3. And then, the rest is 2/3. Okay? So, you can have there 2/3. Okay? So, meron ka doon. Okay, pakita lang natin yan, ano? Pinakita ko lang. So, you have to remember that. Okay? So, ngayon, meron lang tayong 0.2. Okay? So, again, ang load mo doon is meron kang weight. So, ang weight mo is 250 kilogram. But you have to multiply it by 9.81. Okay? So, that it will become force. Next. So, tanggalin natin yung reactions. So, pag tanggalin natin yung supports, palitan natin ng reaction. So, si A again, this is a pin, so meron kang dalawa. So, we can have it as AY and we can have it as AX. Okay, so meron kang dalawa. Pero ito, since this is a roller at point C, so meron kang isang reaction doon which is perpendicular doon sa plane. Ngayon, since nanggaling siya from the horizontal papunta doon sa plane na 30 degrees, yung pinaka-force natin, manggagaling naman siya dito sa vertical. Okay? So, again, that would be your 30 degrees. So, summing up, ito po yung inyong magiging reactions or free body diagram. So, meron kang weight which is 2,453 Newton. Again, that is located at point G. Point 2 mula dito and then point 4 mula dun sa kabila from point C. And then again, meron kang AX and then AY since it is a pin support. Okay? So, dalawa. Now, yung point C naman po natin, so we can have it normal at point C and that is 30 degrees from the vertical. Okay po? So, that is for our reaction. So, meron kang ilang unknowns, meron kang isang unknown, dalawang unknown, at pangatlong unknown. So, it means you have 3 unknowns, meron kang tatlong reactions. So, this is a statically determinate structure. Okay? So, you have drawn already the free body diagram. Okay po? Okay, sample 4.3 from the book of Python. A rigid frame is fabricated by joining the 3 bars with pins at B, C, and D, as shown in the figure A. The frame is loaded by the 1,000-pound force and the 1,200-pound feet couple. The supports consist of a pin at A and a roller support at E. Draw the free body diagram. Okay. So, ano po yung mga external loads natin dyan? So, wala pong ibinigay na weight, okay, yung mga members. So, we consider that as negligible weight, okay? So, meron lang tayong external load, moment. Meron tayong external couple, ano? So, this is our external couple. And ito yung ating external force, which is 1,000 pounds. So, ngayon papalitan natin ng reactions yung mga support. Si point A, since again it is a pin support, okay, sinabi naman po, okay, so si B, C, and D, again, pins din po yun, okay, pero hanggat hindi mo siya tinatanggal, okay, so hindi po may expose yung pinaka-reaction niya. So at this point in time, yung B, C, and D, wala pong naka-expose na reaction dyan. Kasi kapag dinrawing po natin siya as a whole, okay, as a whole pa lang po tayo, okay, ang meron lang tayong external support, okay, external. Ang tawag po kasi natin dito, kapag kinoconnecta niya yung dalawang members, internal support po yun, okay. So yung external support, yun po yung nasa labas ng structure or nasa kanyang extremities. Okay? So, that is on the point A, which is a pin. So, meron tayong dalawa. We can have it as AY and we can have here as our AX. Now, at point E, again, meron tayong roller. Meron lang tayo dyang normal at point A. Okay? So, drawing the free body diagrams, so we can have this kind of free body diagrams. So, meron tayong ilang unknowns, isa, dalawa, and then tatlo. So, meron ka lang 3 unknowns. So, this is a statically determining structure. Again, although yung tatlo ay pin, but they are internal pin or internal support, no? So, hanggat hindi po yan binabaklas. So, later on kasi babaklasin natin yung mga ganyan. Pero hanggat hindi mo siya tinatanggal, okay, hindi po ma-expose yung kanyang reactions. Pero, for example, this is point, anong points to? Example, pinadrawing sa inyo yung free body diagram ng member ABC, for example. So, member ABC, yan. So, again, meron kang A, meron kang B, and then meron kang C. So, for example, okay? So, may expose na ngayon yung inyong AY, AX, meron ka ng BY, and then BX, meron ka ng CY, and then meron ka ng CX. Okay? So, magiging 6 yung unknowns mo. Sir, paano yun? Hindi na siya statically determinate. So, no. So, depende sa dami ng members mo. So, again, yung atin pong pin, internal pin po, okay, masosolve natin siya kasi by action, reaction, ano. So, later on, may mga magka-cancel. So, again, in short, kapag as a whole ka at meron kang tatlong unknowns, again, this is a statically determinate pa rin naman po siya, no? Okay? So, that's how you solve for the free body diagram. Okay? So, that's it for problem 4.3. Let's have this problem 4.4. The beam ABC, yan, meron ka daw beam ABC. Okay? Built into the wall. So, yung beam ABC mo daw, ang sabi niya ay built into the wall at A. Okay? Ito po yun, at A. So, automatic, kapag sinabi natin built into the wall, so it has a fixed support. Okay? And is supported by the cable at point C. Okay? So, sa C, ito po yung point C mo, meron ka daw siya na cable. And carry a distributed load over the part of its length known as uniformly. Meron tayong dalawang klaseng load, ano? Okay. If your load is a rectangular tapos nakakita kayo ng maraming pababa, okay, ang tawag po natin doon is uniformly distributed load. Okay? Kapag naman po nakakita kayo ng loads na nakaslant, okay, paiba-iba, so ang tawag naman natin po doon is uniformly varying load. Okay? So, ayan, pwedeng paganyan, okay, pwedeng trapezoidal. Again, that is a uniformly varying as long as nagva-vary yung load mo from one point to another. So, you have the uniformly varying. Okay? So, kapag ganyan po ang ating problem, okay, para makuha po natin yung resultant nito, parang kinukuha lang natin yung area. So, meron kang length dito, tapos meron kang height dito, which is the magnitude. So, yung pinaka-resultant mo is parang area lang ng rectangle, which is length multiplied by the m. So, ito, okay, para makuha natin yung reactions niya, yung pinaka resultant niya, okay? So, i-multiply po natin yung 1,000 by 3 feet. So, meron ka ng 3,000 pounds, okay? So, acting po siya, since ang rectangle, acting siya gitnang-gitna. So, meron ka dong 1.5 feet, okay? Again, kapag triangle, ano area ng triangle? 1/2, okay? So, yung length mo tsaka yung magnitude, so meron kang 1/2 length multiplied it by the magnitude. Tapos, again, since this is a triangle, naglalay siya 1/3, okay, mula dun sa pinaka 90 degree mo. How about kapag ganito? Hahatiin mo po siya sa dalawa. So that meron kang uniformly distributed on this part and meron kang uniformly varying on this part. Magiging dalawa yung inyong loads. Okay? So, para makuha natin yung tamang free body diagram. Okay? Balik po tayo dito. Okay? So, since meron kang 3,000, okay, i-drawing naman natin yung ating mga reactions. Sabi sa point A, it is built into the wall. So, it is a fix. Pag fix, meron tayong ilang unknowns? Tatlo. You have the vertical, AY. You have the horizontal, AX. And you have a moment of MA. Okay, so for example. So, meron ka na kagad tatlong unknowns. And from here, meron kang tension. Okay, tension at point C. Okay? So, lahat yan ng reactions, ilan ang unknowns? 1, 2, 3, and 4. So, meron kang 4 na unknowns. So, this one is not solvable using a statics. No? Kailangan na po natin ng knowledge sa deformable bodies. Okay? So, ito po yung kanyang free body diagram. Niredraw ko lang. Niredraw lang. Okay? So, again, meron kang 3,000 pound located at 1.5 feet. And then, ayun, meron nga pala tayong weight, no? Binigay pala. So, sabi niya, the weight of the beam is 70 pound per feet. So, it means yung 70 mo, i-multiply mo sa length mo. So, you can have it times 8. So, you can have it as 560. Ayun po. Again, located siya from the center. So, 4 and then 4. Okay? So, this is now a free body diagram of this figure. Okay? Again, the lesson here is you must know how to draw the free body diagram. Okay, so let's have the problem 4. I guess this is 4.1. Okay, so each of the bodies shown is a homogeneous and has a mass of 30 kilograms. Okay, assume friction on all contact surfaces. Draw fully the dimensioned free body diagram for each body and determine the number of unknowns. Okay, so unang mahalaga, sabi niya, meron daw 30 kilograms lahat ng inyong bars. So it means dito sa problem na to, yung 1.5 meters and 1.2 meters by total, meron siyang 30 kilograms. And then again, assume, sabi niya, assume mo na meron kang friction sa kada surface. Okay? So it means yung point A mo, that is may friction. Okay? Pero yung point B, since that is a roller, as you can see, isa lang yung kanyang Okay. So, we can have the reactions at A, okay, to be normal. Okay. One reaction. And then you have a friction. Okay, we have 2. And then, on the roller support, again, perpendicular siya dun sa plane. Nanggaling sa horizontal, yung 30 degrees. So, this one, manggagaling naman siya dun sa vertical of 30 degrees. Okay? So, there's more. So, kailangan din po niya yan ng weight dito. Una, hahatiin natin yan sa dalawa, no? Okay, so let's try to put it this way. Hatiin natin yan dito. Ayan, parang pa ganyan. Sige na nga. Again, itong 1.2, meron po yung force dito. Okay? So, you can have it as weight 1. And then dito din, at gitna, hatiin din natin siya. So, meron ka ditong 1.5. So, again, meron ka naman ditong weight 2. Okay? So, yung weight 1 natin, again, meron kang 30 kilograms. So, kapag tinotal natin yung 30, okay? So, meron kang 30 multiplied it by 9.81 para maging Newton. Ang total weight mo po ay 294.3. Okay? Again, this is now in Newton. However, iyan po yung total. Kailangan nating makuha 1.5 lang. At yan, 1.2, no? So, ang total length po natin is 1.5 plus 1.2. So, ang total length ko po is 1.5 plus 1.2. You have here 2.7 meters. So, yung weight 1, parang percentage lang siya ng total length, ano? So, you have here 1.2 over 2.7 of 294.3. So, yun po yung inyong weight 1. So, you can have it 1.2 over 2.7 times 294.3. So, you can have here 130.8 Newton. Ito ganun din. This time, 1.5 naman yung length niya. So, you can have 1.5 over 2.7 of 294.3. So, you can have 1.7 divided by 1.5 divided by 2.7 times 294.3. So, meron ka po ditong 163.5 Newton. Okay? So, yan na po yung inyong free body diagram, no? So, tanggalin lang natin yung reaction dun sa A and then dun sa point B. Okay po, that's it. Okay, so let's have the same, no? 4.3 nga lang. So, again, meron daw siyang 30 kilograms na weight. Okay, so what we will do, sige, i-draw na natin yung body. So, let's try to draw yung ating body. So, we can have... Okay. So we can have it as point A, and we have here our point B. Alright? So unahin muna natin yung pinaka-external loads. So sabi, again, meron kang 30 kilograms ng weight. So 30 times by 9.81, 294.3. Okay? So external loads natin, ilalagay ko gitnang-gitna. So again, meron ka dong 294.3 Newton. Okay? So, ang distance niya, okay, kalahati, ano? So, sabi, fully dimension. So, sige, lagyan natin ng dimension. Okay. So, you can have here the distance. If that is 0.9, meron kang 0.45 meters. So, 0.45 meters. Okay? Now, you have here a uniformly varying load. Okay? So, sabi natin to have that uniformly varying load, kailangan alam natin yung pinaka-resultant niya, which is R. Tawagin natin R, ano? So, how to solve for the R? So, R is equals to 1/2 of yung base niya, which is 0.6 meters. 0.6, and then its magnitude, which is 800 Newton per meter. So 1/2 base times height. So you can have that 1.5 times 0.6 times 800, or you can have here 240 Newton. Okay, so somewhere at 0. Okay, somewhere here, no? Pwedeng nalagay natin doon. Okay, ilagay mo doon. Okay, so meron kang 240 Newton. Again, its distance mula dito hanggang doon sa pinaka-force mo, that is 2/3. Okay, so 2/3 of 0.6. So that is equal to 0.6, 0.4 meters. Okay? So, those are your external loads. Punta naman tayo sa pinaka-reactions. So, again, at point B, unahin natin point B, madali. It is a cable, so technically, you can have there as your tension. Okay, lagyan mo sige subscript tension at B. Then, no? And then next, dito sa point A, meron ka lang nakaslant na isa. Okay? So, you can have this as normal at A. It is because it is an inclined surface. Okay? Kaya lang sabi, there is a friction in all surface. So, magkakaroon ka rin dito ng isa pang force. Okay? Tawagin naman natin siyang frictional force. Okay? So, lalagyan natin ng, syempre, angle. Okay? If this is 30 degrees from the horizontal, this is now a 30 degrees from the vertical. Okay? And this one from the horizontal, yan din po yung inyong 30 degrees. Okay? So, you can have there your free body diagram, and the number of unknowns is NA, F, and TB. So, you can have here 3 unknowns. Okay? So, you have now your free body diagram for this problem. Okay, so let's have the problem 4.5. The homogeneous beam AB weighs 400 pounds for each support condition shown, A through D. Draw the FBD of the beam and determine the number of unknowns. Okay, so unahin muna ulit natin yung letter A. Okay, so mag-drawing ka muna ng beam. Okay, so draw ka ng beam. Then lagyan mo ng mga points. So let's call that as our point A, and let's call that as our point B. Okay, so unahin muna natin yung kanyang loads. Okay, so sabi niya meron daw siyang weight na ilan? 400 pounds. So you can have it as 400 pounds. So you need to draw also the dimensions. Okay. Okay. So So that is 12 feet. So meron ka ditong 6 feet. And then meron ka dong 6 feet. Okay? So now we need to draw the reactions. So at point A, meron kang hinge or pin. So meron kang dalawang reactions. Isang vertical. So let's call it as our AY. And meron kang horizontal. Okay, so again, meron ka naman dito AX. Okay. And now for the B, since this is a slant, okay, nakaslant yon. So meron tayo dong isa lang na normal. Oops. Sorry. So meron ka lang dong normal. Oops, ayaw. Okay. So meron ka lang normal doon. So tawagin natin yung NB. Okay? However, this NB from the vertical kasi nanggaling siya sa horizontal na 40 degrees. So this time manggagaling siya sa vertical. So this is now your 40 degrees. Okay? So the number of unknowns AX, AY, and NB. So meron kang ilang unknowns? Meron kang 3 unknowns. Okay? So this is now for problem 4.5a. Okay, so let's solve for the problem B. So again, meron ka ulit weight, no? So a problem B, meron kang weight. So lagay natin ulit doon. So we can have here again 400 pounds. Okay, so now we have the reactions. Okay, so at point A, again, that is also a pin. So meron kang dalawa. So you can have it as AY and you can have here as your AX. Okay? And then also at point C, may nakakabit kang cable. So you can have here, ayan, lagyan natin doon. Okay, so tawagin natin siyang tension. Okay? So, since meron siyang angle, okay, naka-angle siya, lalagyan natin siya ng slope. So, 6 and 8, ito, no? 6 and 8. So, both by divisible by 2. So, we can have here, lagyan natin ng 3 and then 4. So, that is the slope. So, this is now the free body diagram for letter C. So, you can have it as 3 unknowns also. Okay? Okay, so that is for the problem 4.5b. Let's have now the problem C. So, ganun pa rin siya, no? So, meron ka pa rin weight. Dito ko naman ilagay. As long as it is passing on the line of action, wala pong problema, no? So, you can have there as 400 pounds. Okay? Now, at point A, okay, check natin. At point A, meron kang roller. So, lalagyan mo siya dito ng normal at A. So, we can have there as normal A. Okay, kasi roller siya, tapos yung surface niya is vertical. Aside from that, from point A also, meron ka ring tension. Okay, so we can call that as the A. Okay, and again, that is in 60 degrees. Okay, next, we can have at point B, meron ka rin po dong 30 degrees. Okay, so meron ka dong tawagin nating TB, and that is now on your 30 degrees. Okay, there are times na si TA and TB, kapag po yung pinaka-cable nyo, for example, okay, gumanyan na, no? Tapos sinabi po ito is frictionless pulley. Frictionless pulley. Yung T mo po dito is also equal sa T mo doon. Okay? Pero pag wala pong sinabi, kagaya po dito sa problem, okay? Yan, again, that's a frictionless pulley. Yan. So, since the problem, yung point na to is hindi naman siya sinabing frictionless pulley, so it means parehas lang sila dong naka-support. No? So, it means that your TA is not necessarily equal to your TB. Therefore, you can have it also as 3 unknowns. Okay, so you can have it as 3 unknowns. Okay? Sige po. And then, sige, tuloy na natin. So, lastly, we can have it as point D. Okay? Okay. So, sa point D mo, again, meron ka ulit na weight. Okay, so you can have there your weight, which is equals to 400 pounds. Okay, so again, that's 6 and 6. So, check natin dito. Since yung point A mo, okay, ito is a fixed. So, meron ka dapat tatlo. So, 1, 2, and then 3. So, you can have it as AY, AX, and then MA. Okay? So, here, meron kang roller, so meron ka lang dito. So, you can have it as ND. Okay? So, meron kang 4 unknowns. Okay? So, ito po ay statically indeterminate structure. So, hindi na po natin siya masasolve using our statics. Okay? So, kailangan na natin siyang gamitan ng deformable or gagamitan natin siya ng theory of structures. Okay? So, but for now, dapat alam natin mag-draw ng ating mga free body diagrams. Okay? Ang tawag po sa beam na to kapag yung isa ay naka-fix, tapos yung kabila end ay naka-simply supported. When I say simply supported, okay, when I say simple support, okay, it is just a hinge or it is just a roller. Okay? So kapag yung isang end mo ay naka-fixed at yung isang end mo ay naka-simple support, ang tawag po dito is a propped beam. Okay, ang tawag po dyan ay prop. Anyway, you will still encounter that when you go along with your theory of structures. Okay, so that's it for this problem. Okay, so let's have the problem 4.7, the bracket of negligible weight. So, ibig sabihin, hindi natin consider yung weight ng bracket. Is supported by pin at A and a frictionless peg at B. So, which can slide in the slot in the bracket. Draw the FBD of the bracket if theta A is 45 degrees and B if it is 90 degrees, and what are the unknowns. Okay. So, for example, ito yung slot, tapos ito yung pinaka-peg mo. Okay? So, kapag frictionless siya, it is free to move back and forth, no? Pero kasi kung may friction siya, medyo may hirapan kang mag-move, di ba? Kaya nga yung iba, pag kinakalawang, di ba, ang hirap niyang i-move. It is because meron na siyang friction. So, ginagawa nila lagi ng lubricant or ng oil para siya maging smooth. Okay? So, again, that is a kind of roller. So, what we do is to draw the bracket itself. No? I-draw nyo muna yung bracket. Okay? So, draw natin. So, for example, I have here, and then lagay nyo na lang yung point A, point B, and of course, this one. Okay? So, lagyan natin ng naming. We can have A, B, and then C na lang. Okay? Ngayon, external load muna tayo. So, meron lang tayong external moment here. So, we can have there as 56 pound-feet. Okay? So, now let us now draw our reactions. At point A, you can have that as a pin. So, you can have only the vertical. And you can have here a horizontal. Okay? So, tawagin natin yung AY. And then, tawagin natin tong AX because it is a pin. However, on point B, so meron ka daw inclination around 45 degree. So, it is a roller. So, ang gagawin natin, you can have put that a 90 degree. Okay? Perpendicular doon. Okay? Tawagin natin yung normal at B. Okay? And if this is a 45 degree angle, okay, with the horizontal, So, magkakaroon siya from the vertical. That is now 45 degree also. Okay? So, now, ang mga unknowns natin, AX, AY, and the NE. Okay? So, ganun lang po yung 4.7a. Okay? Okay, so let's proceed with 4.9. The high pressure water cock is rigidly attached. Okay, so ayan, may clue ulit tayo. Sabi niya, rigidly attached. So what does it mean? So it means, yung pinaka-reaction mo sa D is a fixed, no? So wala ka namang ibang force doon. So ang gagawin mo lang, mahirap i-drawing, ano? Tanggalin natin yung support sa D, pero palitan natin siya ng rigid. So meron ka ditong dx, then meron ka ditong dy, and then meron ka rin ditong md. Okay? So, ganyan lang. Okay? So, yan na yung pinaka-free body diagram mo nung pinaka-water cock. Okay po? So, that's 4.9. Okay, so let's draw an FBD of member C of the frame described in the previous problem. How many unknowns appear on this FBD? Okay. So, ang tinatanong lang dito is the member CE. So, eto lang yun. Dito, drawing mo lang yung member CE. Okay. So, drawing lang natin yung member CE. Okay. So, you have there member CE. So, this is C, point C, point D, and then point E. Okay. So, lagyan mo ng name. C, D, and then E. Okay? So, now, meron kang external force doon sa member D. Okay? So, nandito siya. So, let's have that here, somewhere here. So, you can have there. Okay? Ano yung value niya? So, yung value niya, meron kang 20 times 4. So, we can have it as 20 times 4, so you can have it as 80 pounds. Okay, and its distance from here hanggang doon, so you can have it as 2 feet, kalahati ng 4, ano? Okay, and then we may now draw the reaction. Okay, at point C, wala po yung reaction, no? That is a free end. However, at point D, meron kang slat, so that is a roller. And then, yung pagka-roller arm, pagka-slat niya is horizontal, ano? So, meron ka lang, ito lang tumatama sa kanya. So, meron ka dong reaction. So, you can have there as ND or normal sa D. At point E, meron kang dalawa. So, since it is a pin, internal po yun. So, again, pag binaklas po natin, kagaya ng sinabi ko kanina, kapag binaklas mo na yung member CE o iniwalay mo na sa kanila, lahat po ng internal support ay ma-expose na. Okay? So, magkakaroon ka na rito ng EY at magkakaroon ka na dito ng EX. Okay? So, iyan na po yung inyong pinaka-free body diagram. Okay? So, that's it for the free body diagram. And then, the next lesson would be the determinations now of the reactions. Okay? Sige po.